Hello guys, your exam yesterday hopefully was easy. As you noticed, theoretical questions, a little bit of programming, if you know how to do a class, main method, and conditions or something. Hopefully it was something that you finished in 45 minutes or less. Usually students get a high grade in the first one. You can expect something like that, I mean, statistically speaking. So things are going to be more interesting for the second and final exam. So let's see. The goal is for this week during the labs, the TAs are going to review the exam with you after we finish with the grading. One of the labs, hopefully this week, is going to be about reviewing the exam. So any questions that you could have regarding your grade, regarding any of the questions, you're going to have the opportunity to review that during the lab. Remember, second midterm and final exam, they are comprehensive. So any of the questions in the midterm can be again in the second midterm or in the final. So if by any chance you get wrong one of the questions, if you were not able to answer something, please review that. So hopefully if the same question is in one of the following exams, you perform better. Good. The exam should be great. I mean, my instructions to the TA is for them to finish this week. There are a lot of exams to grade, and we do not release grades until we finish with everyone. So hopefully this week, but they are going to keep you posted. Well, I think reading the question in the chat, as I mentioned before, you're going to review your exam during one of the labs. So any question you can review with the TA during the lab. That's it. If you have any further questions that the TAs cannot answer during the lab, you can send an email to me and we can take a look. Good? So that is about the exam. And again, it's an easy exam. Usually people perform very well in this first exam. So things are going to become more interesting for the next ones. So far, doing a quick review, what you know is, besides theory, you can create a program with only one class. I mean, that is what you did. So far, the most usual thing that you do is work in one method. Usually that method has been main. And almost everything that we're doing is inside of main so far. One thing that is going to change is the following. At this point, your programs start here in the first line inside of main and go down running line by line. That was our first step. Then in the previous week, we start learning about control statements. And we review the first group of control statements. We review the conditional statements. And with the conditions, something that we learn is that the flow of your program can start here, but not always is going to go down just like a straight line. We can jump some instructions. So avoid a particular instruction to be executed using if, or we have maybe two different paths. So according with a particular condition, we can execute one instruction or a different one, but then we continue down. So far, we have these two options: align top down, or we have this if, else, switch, and so on that allow us to control that maybe only one line in a group, like in the switch, or two options, like in the if, else, and we can nest instructions, so we can create two paths, and one of those two paths divide in another two, and so on. So we can create different combination of paths. But at the end, my program starts here, and in some point, it's going to achieve the last line in the method, the last line of main. So this is kind of the big summary of our previous 3 weeks. And for today, I want to continue with the control structures. If you remember, control structures, we review conditions. The others are the loops. This week, I want to review loops with you. So the big pictures of the things that you know is this slide in particular. You know classes, you know global variables, you know the methods, and everything that we have been reviewing is inside of the method, the statements. And we review local variables. Inside of the method, a variable is a local variable. We review instructions. You know the math class that you use in the exam. We review this G option pane from the libraries. And we have obviously the print ln. So we have a set of instructions that we are using. We know about variables and data types. And also, now we know about the conditional statements. You can create if, else, switch, so on. Moving forward, this week, we need to review another kind of a statement, the loop statements. That is what we're going to do today, tomorrow, and the loop statements. We have 3 different options to create loops in a program. Remember, for conditions, we have this if else, switch, and the question mark operator. Those was the options. Now, for the loop statements, we need to review 3 options: while, do while, and the for loop. And yes, those are keywords, more words that I am asking you to memorize: while, do while, and for. Important thing here, 2 completely different things, and we're going to review them today. We have this statement, while, that is the keyword, and we have another one, different from the previous one. We're going to review the difference today. That is do while, 2 words. I put here this line used to separate the words. They are 2 different things. We're going to review where those 2 words go in a sentence, but 2 different instructions: while alone, and do and while together, and then the for loop. For today, my goal is while and do while, and maybe we review for tomorrow, so we complete the loop statement this week. So moving forward, just as we did with the if. The first thing that I need to tell you is about the rule. If these things are statements, the first thing that you need to do to know is, well, what is the grammatical rule for that statement? What are the words that we need to use that statement? Let's see. While statement first. For the while statement, that box, that is the thing that I need you to memorize. That is the rule for creating a while statement. I am going to explain first the grammatical rule, so how to create the statement, and then we're going to review what this statement is going to do in your program. So the statement, number 1, if we want to create a while statement, the first thing that we need is the keyword while. Lowercase, everything lowercase. That is going to be the first thing. Then, open parentheses, closing parentheses. Mandatory. inside of the parentheses, just like for the if condition, you put inside of the parentheses a condition. A condition, anything that at the end have as a result true or false. It looks like the if condition. It looks like the if statement. Yes, it looks like the same. The only thing, obviously, you are changing if for while. And the result that you are going to get is a little bit different. But the keyword, while, parentheses, and inside you have a condition. A condition, anything that gives you true or false, that means you can use relational operators, logic operators, and you can create crazy conditions, just like we did before with the if. Anything that results in a true or false at the end, doesn't matter how long, can be here. Next, open curly brackets and closing curly brackets. This open curly bracket can be here. Yes, remember, enters, tabs, and so on. The computer don't care. So this one, you put there, good. You can put everything in one line, good. The only reason because I put the enters is to try to show you something. So while, parentheses, a condition inside, open and closing curly brackets. Identical almost to the if, right? Good. Now, inside of the curly brackets, instructions, statements. Which ones? Well, statements, anything. You can put inside an if condition. You can put inside another while. You can put inside a print. You can put inside an instruction map something. Remember, anything. Okay, that's it. That's it. What is the difference between the if condition and this while? Well, very, very simple. If you remember, for the if, you can have something like, I have this variable int x equal 5. And then I can do something like if x equal 5, system out print ln type, and then x equal x minus 1, closing, system out print ln by. Use a program, anything, you can put this inside of a main method, whatever. And obviously my question in your exam, for instance, is what this program is going to do? What is going to be printed on the screen? Well, you know, I mean, you answer something like this in your exam, and at this point, you have experience knowing that, well, if the variable x is equal to 5, that is an assignation, then you come here and you check the condition, and because the condition is true, then you're going to execute whatever you have inside of the curly brackets, and here I am going to print hi. Also, I am going to execute the second line, and then when I finish, I am going to print this line that is outside of the if. If I change the value for the 5 and I put a different value, like a 3 or something, then these two lines are not going to be executed, and the only thing that I'm going to have is the by. That's it, a condition. So this guy, the only thing that do is whether or not these lines here are executed one time, right? Or never. So 1 or 0 for the two lines inside of it. What happened in a loop statement when the only thing that I am going to do is to delete the if and tell the computer here a different keyword. That is the only thing that I did. I do not want an if. Now I want a while. Two different things. Same condition, something inside of the curly bracket. That's it. The while is a loop. And what is going to happen is the following. Step number 1. The program is going to start here. The program is going to run this x equal 5. It's going to go down, just like before. Here, the program, you have a while, good for you. The only thing that I am going to do is to check the condition. The condition is true. Good. I am going to execute the two lines that you have inside of the curly bracket. So far, exactly the same that the if. The difference, when you have a while and the computer reads this closing curly bracket, what the computer is going to do is from this point, it's going to jump to the while again. And that is a loop. So, because I have a while, the computer is going to remember, oh, okay, you have a while here. It's going to check the condition. It's going to run the instructions inside if the condition is true. And when you reach this closing curly bracket, the computer is going to jump back to the while. That is a loop. It's going to jump because you put while. And while is a loop. And that loop is always from this point, go back to the while. Now, what is going to happen in my example? You jump back to the while, and the computer is going to check this condition. And again, if the condition is true, it's going to run these lines. When reach this closing curly bracket, it's going to jump again, check the condition. If the condition is true, run the lines, and it's going to be there forever. What can I do if I want to stop this loop? The only thing that I can do is something that makes this condition false. When the condition is false, what is going to happen, just like with the if, because the condition is false, the program is going to jump to the next line after you close the curly bracket. If you remember, it's the same behavior that you have with the if. Condition false, you jump the instructions inside of the if. In this case, condition false, you jump the instructions inside of the while. But the big difference is when the condition is true, you not only do the instructions, but also jump back to the while again. So I am going to go back to this example, but the easy example that I can think about while is if I create a program with something like this, and I put a condition like this, and inside that's it. My question for you in the exam, how many times hello is going to be printed on the screen? Forever. You can try. If you put this program in your computer, your computer is going to be forever printing hello. And why? Because I start here, I check the condition is true, run the instruction inside, reach the curly bracket, and jump to the while. And there is any way that that condition is going to be false in this program? Never. I mean, the condition x equal 1 is going to be true forever. Your computer is going to be forever printing hello on the screen. The question is, what can I do to make the condition false? Because somehow, maybe, I can make the condition false. Option number 1, and you're going to solve this thing several times when you work with whiles. In your exam, how many times this program is going to print hello? How do you know that it's going to be 1? Well, because we start here, we check the condition is 1 equal 1, is true. We go inside, run this line, but then we change the value for the variable. So when we go back and we reach the closing curly bracket, the closing curly bracket is going to jump to the while. But this second time, when you're checking the condition, now the condition is false, because now x is 2 and 2 is not equal to 1. So this loop, the second time, is going to go and continue the program there. You can think like, well, okay, an infinite loop is not a good idea because my computer is going to be there forever printing hello. But the solution, well, maybe it's not a good idea either because we're going to print hello only one time. And to print hello one time, you can ignore the loop. Right? You do not need a loop to do something one time. So maybe you want to do something a little bit different, like printing hello 5 times or 10 times or something. I mean, you want to control how many times you want to do this. Well, the only thing that we need to do is to play with the variable, but the statement is going to be the same. For instance, a common example that you're going to review in the book or online or in my slides. What if we do, playing with the variables, something like, let me change the condition and let me change this sentence here. If I play with those things, well, let's make the condition something like, instead of equal, we can use another operator like lower than, and we can do something with the variable using arithmetic operator. The only thing that I change is the blue thing, right? Tell me, can you imagine how many times hello is going to be printed on the screen with this new block of instructions? How many times the condition is going to be true? And we can play, right? The first time, our program starts here. The variable x is 1. We're going to go down. We're going to write here. And the question is going to be 1 is lower than 10. And obviously, that is going to be true, right? And because that one is true, we're going to print hello the first time. And then the variable is going to change. And now, instead of being 1, like at the beginning, now it's going to be 1 plus 1. Remember, the plot go first. So that is going to be 2. And then the equal is the lowest precedence operator. So the 2 is the one that is going to be stored in the X. And that means that the one that I had before, goodbye. And now the value for X is 2. You go down, and because you're using while, you go back there. Second time that you are in that point, second time, and now you're going to check the condition. And this time, the condition is 2, because you change the value of the variable, right? Lower than them. And it's like 2 lower than them is still true. You are going to go inside, second time that you print hello. That is the second hello that you have on the screen. You are going to continue down. And now you are asking for 2 plus 1, 3. And X is going to be equal to 3. So now your variable is 3. And you go back. And now you're going to compare if 3 is lower than 10. You are going to print, and your variable is going to become 4. Go back. 4 lower than 10. You are going to print, and your variable is going to become 5. Go back. 5 lower than 10. You are going to print. Your variable is going to become 6. You are going to go back. 6 lower than 10. You are going to print. Your variable becomes 7. 7 lower than 10. You are going to print. Your variable become 8. 8 lower than 10. You are going to print. Your variable become 9. 9 lower than 10. Print. Your variable become 10. And now you have 10 lower than 10. 10 is lower than 10. Finally here is false, right? Finally, the condition is false. And when the condition is false, we go out of the loop. So how many times do we print hello? 1, 2. Can you agree with that? 9 times. Just reviewing what happened, right? 9 times. Yes, because if you review, you start with the variable 1, and then you're looking for this value that is lower than 10. The last value that is lower than 10 is 9. So increasing in 1, you run this loop 9 times. Whatever instructions you put here are going to be executed 9 times. I am playing with this print hello, but you can print numbers, you can print information, you can do a condition here. Anything that you want inside of the loop. So far, makes sense. Loops, our first instruction. Why? What happens here? Good? Questions? On the chat? No? Good. So, going back to the slides. The only thing to remember is when you play with loops, this point, go back to the keyword, go back to check the condition. That is the only new thing for this week, this jump that the computer do. Now, in a picture, do you remember that I showed you something like this for the if condition, and basically was a tree? You have a beginning, and then you go back and create branches. Here, the key idea is not these branches, these several paths, but the key idea is a loop. Go down, reach the closing point, and go back to the beginning until the condition is false. True, continue in the loop. False, move to the next instruction, to the instructions that follow the while. An example. Can you explain me why this program is printing 2, 3, and 4? Hopefully, yes. Now, what should I do if I want to print 1, 2, 3, and 4? And this is the point in which we start doing programming. What do I need to do in this piece of software if the only thing that I need is also print the 1? Because right now I am printing 2, 3, and 4. Two solutions. Something that we mentioned before, and I need to insist on that, is we're learning a language. When you learn a language, there are many ways in which you can state the same idea. So I am sure that 50% of you and 50% of you are thinking about two different solutions. One solution, the easy one. Some of you notice, comparing this with the previous one, that, well, what about you switch these two lines? What about you switch the 7 and the 8? What about you print first and then you change the value? If you do that, you have what you want. That is option number one. And usually, if I make a survey, 50%, maybe more, because the influence of the previous example, can be thinking like, that is a solution. Okay, a second solution. Someone you mentioned in the chat, it's like, well, if right now you're printing 2, 3, and 4, but you want to start printing in 1, well, what about here, make x equal to 0? That can work. Two ideas, two different programs. The final result is the same. Which one is better? Both are good options. It's just your way of solving problems. You like the variable to start in 0, even though you're going to print the 1. You want to start the variable with 1 because that is the first number that you're going to print. It's entirely up to you. The important thing is you solve the problem using the tools that you have. And in this case, the tool that we're reviewing is this idea with the loops. Important thing here, always, 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 when you work with a while statement, hopefully at this point, I put the idea that the only thing that you can do to stop the loop, to avoid having this infinite loop, to avoid having your program doing something forever, is the condition. And in particular, the only thing that you can do in the condition is change the value of one of the variables. If you change the value of one or more variables inside of the body of the while, that is the thing that you need to do to figure out in order to stop the condition. Play with the condition. Play with one or more of the variables. That is the tricky part of the while. That is something that you need to practice, because that is the only thing that is going to make the difference between a program that is working correctly and a program that is doing something forever. Someone mentioned in the chat an infinite loop. Now, before moving forward, talking about an infinite loop, one question for you. An infinite loop is an error. Do you think that having an infinite loop is an error in a program? Or maybe an infinite loop is just another feature in a program. An infinite loop is not an error. Good, I like the answer in the chat. Can you think about one program that you use that work with an infinite loop? Any program that you use maybe every day that works with infinite loop? I am not sure if you play games every day, but yes, a game is one of those programs that use infinite loops. In particular, I'm moving something that you are using. You use Canvas, right? In general, you use your browser, you connect to the internet. Any web server, any place on the internet that you connect with, like Canvas or ASU, that Canvas server, that web server is an infinite loop, a while or a do while, running forever, checking if there are users connecting. Web servers are programs that use an infinite loop as something that is useful. So my point here, guys, infinite loops are not errors. It could be an error in your program if you do not want an infinite loop in your program. It is an error if you want to print something 10 times, but you get hello forever. However, my point is, in some programs, having an infinite loop is something that I want to have, period. Good? Loops, infinite loops, could be useful depending on what you are doing. And well, you mentioned several examples on the chat. My point is there is at least one example of a program that uses infinite loop. My example usually is the web server, just because I am sure that all of you use Canvas. But yes, we can go to the hardware software, software running in hardware. We can go with video games, and we can go with several other things that you can think about it, programs that you use, that they need infinite loops. Programs that are running forever, doing something, like waiting for a connection. Anyway, so moving forward, something that you're going to do in your next exam, but something that you're going to do when you're programming is several times. If you need to do something 2 times, 3 times, several times, what you do is to think about which loop statement you're going to use. And once you select the statement, your next problem is what is going to be the condition. And once you have the condition, what we are going to do, one variable or more, to stop that loop. That's it. Good. Now, how many times you think a while loop can run? Hopefully you agree with me that, and this is a question for your exam, the while can run 0 or more times. What could happen for these instructions here to run 0 times, never be executed? The condition is false, right? I mean, think about it. I create a while loop, and what if I put as a condition 5 lower than 0? You like that? Is my condition correct? Talking about error, it's going to compile. Okay, it's correct. And be careful, guys. If I put in my program 5 lower than 0, the statement compiles. The condition is correct. I have a number, an operator, and another number. It's correct. Now, you can tell me it's false. Okay, the result is false. But the question is a correct question. I am asking, 5 is lower than 0? False. I have a question, an operation, and I get a result. Everything is fine. False, that is the result. Therefore, if I do a while with that condition, whatever I have here is going to be executed 0 times, never. Because the first time that I arrive here, the condition is false, the program is going to continue here, never touch the instructions inside. And the opposite is, if this condition is 5 lower than 10, just like that, this loop is going to be true. It's going to be executed 1 time. And the second and the third one is going to stop in some point? Never. What can I do to stop this? Nothing. You're using numbers, and there is no way that the condition is going to be false, right? I mean, forever, that condition is going to be true. This condition is going to be running, and it's going to be true forever. This loop is going to run forever. Well, if you change this, and instead of a number, you put some kind of variable there, like x lower than 10, well, then you can play with x, and maybe here inside, somehow change the value for x, and therefore define a stop point. So the while loop can run 0 or more times. More, 1, 2, 3, 10, 100, forever. If I put this, answering the question in the chat, if I do something like while 5 lower than 10, and then inside I put system out println by, and I close. And the question for your exam could be how many times by is going to be printed. The answer is forever. It's an infinite loop. Just because, as we mentioned before, this condition is true, never is going to stop. In fact, another condition here. Can I do something like while parentheses yeah, right? True? Yeah, true is a value, remember? It's a keyword. Yes, but also it's a value. It's a value for a Boolean variable. Remember, Boolean variables can be true or false. They are values. So can I put the value true there? Yes. And this condition is going to be true. And when it's going to stop? Never. It's true forever. Can I do the opposite? Can I put a while and that one is going to compile? Yes. That one is correct? Yes. How many times that one is going to run? 0 is false. And when is going to be true? Never. It's going to be false forever. So this one is something that you can put in your compilers. It's something that can work. Yes. That one is correct in the language. Yes. There is any reason because you are going to create a program with something like this? I don't think so. Not with false. Because do not make sense. However, that line, if you review the source code of a web server, you have this line. If you review the source code of your games doing something forever, that is the line. Why? Because it doesn't make sense here to put any condition like relational operators or something. I can put true directly. And what I am telling to the computer is, computer, this is going to be an infinite loop. So this loop is going to be running forever. So I tell you, this condition is going to be true forever. So relax, and whatever I'm going to put inside, you're going to be doing that forever. That makes sense. So true is something that you're going to check in your programs. True is something that you can find if you search for source code online. The false do not make sense. It's correct, yes, it's correct. It's something that you can do with the language. It's something that you can do, but it do not have any useful application. Yes, answering the question in the chat, yes, you can do that. Anything that you can put in a condition, you can do it. Anything. Questions? Now that you know how to use the while. In your exam, can you create a program that print all the numbers 1 to 10? I mean, I want a program, and the only thing that I want is that program printing the numbers 1 to 10. Without using the compiler, just like in the exam, you have a window, I have a piece of paper, do a program that print the numbers 1 to 10. Hopefully, right now, in your mind, you're thinking like, well, I will need a variable, and I will need a variable. I am going to use a different name, that X, just to change the stimuli. That variable can be an integer, right? In fact, just to play a little bit here, do you allow me to use byte instead of int? I mean, I can use int. The only reason to change the type is to play with other things, right? Now, I can start with 1. And then you're asking me to do 10 times something. Option number 1, you can put system out println 1. Option, system out println 2, system out println 3, and so on. You can put 10 instructions system out println. But what if I ask you to print the number 1 to 100, or 1,000, or 1 million? This copy paste of the instructions usually is not a good idea, right? So hopefully you can think like, well, I can use a while, use a loop. And then you're asking me to use print something several times and close it. Main idea, if I ask you to print the numbers 1 to 10, my expectation is 1, you know that you need a variable. 2, you know that you need a loop. 3, you know that you need the instruction for printing. And the instruction for printing is going to be inside of the instruction for the loop. What is the hard part of the problem? What is the thing that we are going to be evaluating in your exam? Or what is the thing that is going to take more time when you want to do software? Really, the hard part is not to memorize the keywords. It's not to remember the rules. Because I am sure that now you have in your mind the grammatical rule for while. It's very simple. The challenge in programming is, okay, what is going to be the condition for the while? What I am going to do with the variable in order to tell the computer that I want you computer to print all the numbers 1 to 10. Hopefully, and this is the main thing for you to practice, it's like, well, if you want to do something 1 to 10, maybe, just maybe, an idea could be that you want this number to be lower than 11, assuming that you are starting with the value 1. So that is the first idea. Now, if I put this and finish, how many times I am going to be printing whatever is here in this example? Hope you notice, if I stop here, compile and run, this is a loop that is going to run forever. And it's going to run forever because this condition is true. Num is 1, lower than 11, true. And just because I am not changing the value inside, that true is going to run forever. Your main problem working with loops is that sometimes without being the goal, you are going to be creating infinite loops. That happened to everyone. So that is the first issue. Remember, be careful with the infinite loop. This one is an infinite loop. So what I need to do is change the value for the variable. And just because I want to move 1 to 10, well, the solution that you provide to me is, well, you want to change the value for the variable, num. And maybe what you want is make num plus 1. So you're going to be 1, 2, 3, and so on. And why not? The thing that I want to print here is num, right? I want to print the value of the number. Can you agree that this program solved what I asked you to do, to print the numbers 1 to 10? What happened if, by any chance, I make a mistake? For any reason, I am working, and instead of a plus, I put here a minus. My fault, I put a minus there. What is going to happen in the program? Hopefully everyone agrees you have an infinite loop again. Because the first time, 1 is lower than 11, but the second time, 0 is lower than 11. Minus 1 is lower than 11. Minus 2 is lower than 11. And the number is going to continue going down. The condition is going to be true forever. So something important here, guys, is for the first time, and this is going to continue, a small mistake. Because it's like, instead of a plus, I put a minus. It's just almost nothing. Well, your minus create an infinite loop. Your plus print the numbers 1 to 10. This is the part in which programming is challenging. This is the part in which, when you are telling the computer what to do, a small mistake can create some kind of problems. Be careful. So, one recommendation, never, never, never create a program and write everything and compile and run at the end. Never do that. My advice, if you're doing a program and we're going to do something big next week or at the end of this week, always do something small, 10 lines, and check that it's working. Another 10 lines, check that it's working, and so on. Because if you just start doing everything and you create a 100 lines program, it's going to be very, very hard to find errors. Just like this is more minus, that should be a plus. You do not want to do that. Okay, this is what. Back here. Infinite loops, you understand the concept, and you know that there is not an error. It's something that sometimes is useful. This program, if I told you that this program is printing 1 forever, can you agree? Important thing, this line, do you remember what is the meaning of these two guys at the beginning of the line, right? It's a comment. So this is the point in which we're going to look and we're going to have comments. And I need you to remember that this line 7 in this program is not there. It's a comment. My point is, if I do not have that line, if I put that line in a comment, if I do not change the value for the variable, the result is this: forever printing 1, forever the condition being true. Obviously, what happens if I remove the comment? What happens if I make that x equal x plus 1 be there? Well, that is the example that we had before, right? That is the example that print 2, 3, and 4. Good? So, why? Good. Now, do you remember that you can put an if inside of an if? We can put a loop inside of a loop. In fact, we can put ifs inside of loops, and we can put loops inside of if. We're going to play with that later. But for now, and just checking loops, we can put loops inside of loops. And what we have is nested loops, like this one. Do we understand what is happening? Do we understand this result? And in this point, something that I will recommend you to do is the following. This is a class, this is a method, and we know that our program starts here. And in some point, if we do not have infinite loops, our program needs to finish here. Somehow we need to move down, and somehow we need to reach that point. In this example, I have a variable. My variable is x, right? This line. How many times I am going to execute the line 5? Hopefully, we have clear that line number 5 is going to run 1 time, period. Why only 1? Because that line is not inside of any loop. And the only option to execute one line several times is if I put the line inside of a loop. So x is going to be 1 in line 5, and that is going to happen only 1 time. And my advice for you is, you can create this box, put the name of the variable and put the value, just to remember that you have that variable, and just to remember what do you have in that variable. In this case, x has the 1. I am going to go to the line 7, and I am going to check the condition. True or false, the condition. X lower than 4. I check my box, 1 lower than 4, condition true. I am going to move to the line 8. Notice that I am using these tabs, trying to show you what is inside of what. My goal is that just looking to the program, you notice that the while that starts in the line 7 is going to end in the line 14. So everything that I have in the line 8 to 13 is inside of that loop. So that is the reason for the tab. And because everything is inside, then all of that is going to happen or not, depending on that particular condition. So it is true, go inside of the line 8. Inside of the line 8, what is going to happen? X equal x plus 1. And this is the reason because I put my box there with the 1. Because in that point, the operation is going to happen x plus 1, 1 plus 1. 1 plus 1 is 2. And where I am going to store the 2? In x. What is going to happen with the 1? Goodbye to the 1. Now, what you're going to have is a 2 here. Something important for you when you're reviewing a program is the x is 2, not 1 anymore. Next, Did you notice that variable there? I am creating a variable in the while. And my variable is 1. Y equal 1. Okay. I run this line, I run this line. Oh, I have a while inside of the while. Can I do that? Yes, it's an instruction. The while have instructions inside, and you can have another while. So condition, y lower than 4. True, right? Y is 1, is lower than 4, is true. Second condition that is true. What is going to happen? I go inside to this line. I am going to print the value for x. And hopefully you agree, I am going to print x, and x is this 2. So that is the one that is printing the first 2 that I have here in the result. I am printing a 2. Okay, next. I go down, y equal y plus 1. Now this y is 2, not 1 anymore. It's 2, and this is the first time that I reach the closing curly bracket. Now, that closing curly bracket is the closing curly bracket for a while, right? And the only thing that here is very, very important for you is, can you agree with me that this closing curly bracket is going to jump the execution of the program from this point to this point? It's going to jump to the line 10, or it's going to jump to the line 7? Hope you agree that to the line 10. Think about this while inside of a while like parentheses, opening and close. If you open a parenthesis here and you close here, well, when you put something inside, the closing of this one is the one that is close to this. These two are going to open and close first, and then the one that you have outside. So something similar for the whiles is the closing curly bracket in 13 is the one that corresponds to the while in 10, not to the while in 7. The while in 7 is going to close down to the 14 or something. So from 13, jump back to 10. I am still inside of a loop, but I am running another loop. So what about the condition now? What is the value for y? 2, lower than 4. Yes, go inside. Print x. What is the value for x? Still 2. That is the one that is going to print the second 2. Good. Now what is going to happen? Y, 2, plus 1, 3, and store the 3 in y. Now this guy here is going to be 3. Goodbye to the 2. Again, in the closing curly bracket, jump to the 10. Condition, y is lower than 4. Y is 3. Lower than 4? Yes. True. Because it's true, go to the line 11. In the line 11, print x. X is still 2. And y is equal to y plus 1. 3 plus 1, 4. Store the 4 in y. This one is going to become 4. And closing curly bracket, go to the line 10. And now the condition is 4 lower than 4. And it's going to be false. Finally, it's going to be false. What happened when it's false? Well, from this point, we're going to go and continue to the next line after the closing curly bracket, right? That next line is the closing curly bracket for the other one. So I want you to notice that in this program, when the condition is false in the line 10, you jump to the line 13, you jump to the line 14, below the 13, and for the 14, you jump to the 7. So from the 10 to the 7 in this, yeah. So very good point. This one, only the first time is making a new variable. That's it. I can create this y outside with the other. I can create this y there. Remember, you cannot have more than one variable with the same name. So in this case, only one y, only the first time you create the variable. Now, what happened when you jump to the 7? You jump to the 7, and my point is, I can check the value for x. 2. Lower than 4. Yes. You go inside. You go inside, and when you go inside is 2 plus 1, 3, and store 3 in x. This is going to become a 3. Go down, and you have again this instruction about y equal 1. Just because you already have this y, the only thing that is going to happen is, okay, you want a y? I'm going to have a 1 there. Do you remember I have a 4? That 4 goodbye, and the value inside is going to be 1. I am going back to the y equal 1. I am inside of the second time that I run the while in the line 7. And starting here, what is going to happen is everything that I did before is going to happen again. Everything that I did before, this y equal 1, and then 2, and 3, that is what is going to print these values. If you notice, again, I am printing the values that basically correspond to the value of x, and now the value of x is 3. And I am printing those values 3 times just because I have a loop inside printing 3 times whatever value is created in the loop outside. And you can be thinking like, why are you doing this? Well, this program, my only goal is to show you what happens when you put one loop inside of another loop. Later, we're going to play with some more useful or more interesting examples. But in this point, my goal is to show you what happens when you put a loop inside of a loop. My goal, the loop inside can be running, and when go out, well, you are in the loop outside. And then you do the loop inside and the loop outside. 2 conditions, and you are just basically running, running, running. Makes sense. This is a key concept in programming. And as you notice, the lines, the paths can go crazy. My request for you, please practice. Copy these programs, run the programs, and do not be afraid of changing things, and see what happens when you change things. Right now, I am printing the numbers 3 times. What happens if I tell you, you know what? I want a program that print the numbers 1 to 10 and each number 10 times. So I want 10 ones, 10 twos, 10 threes, and so on. Hopefully by now you have an idea of what you can do to print the numbers 1 to 10 and each number 10 times. Something that you can do for practice. Make sense? Hopefully, yes. Okay. Now, quickly, the do while statement. Do while statement. This is the grammatical rule. And I want you to notice the difference with the previous one. The rule for a do while statement. Number 1, keyword do. Number 2, open and closing curly brackets. Remember, I put an enter, but this open curly bracket can be in the same line. You can have everything in one line. So keyword do is a keyword. Open and closing curly bracket. Your instructions go inside. And now the while with the condition are after the closing curly bracket. Remember, in the previous one, the while and the condition were before the open curly bracket. Now I put while and the condition after the closing curly bracket. And just because I need another keyword to be here, I put the do. And that makes the do while statement. Do, the word that opened the statement, and while closing the statement. Now, notice also that because I put the while and the condition, something that the language asks me to do is to put a semicolon after the condition. Why I put the semicolon? Well, because the computer needs to know that that one is a closing while. Because if you do not put the semicolon, the computer is not going to understand if maybe, just maybe, this while here could have a curly bracket. So just to be sure that this is not what you are doing, the computer asks you to put the closing curly bracket there. So the computer knows that that while is not a new statement, but that one is the closing of the previous one. Okay, so what I am going to have, this is what you're going to have. You're going to have a loop, but now int x equals 1, do, curly brackets, system out, print ln, and I want to print hello as usual, and then closing curly bracket, I am going to put here a condition, and my condition is going to be something like, you know what, while x is greater than that, and semicolon, do not forget the semicolon. Here, condition true or false? X greater than 10, false. Okay. How many times this hello is going to be printed? Variable, do, print, and here I check the condition. If the condition is true from the semicolon, I am going to jump to the do. If the condition is false, I am just going from the semicolon down to the next statement. Do while. Always, always, always execute the instructions at least one time. Why? Because you check the condition after the instructions. The while, always, 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 is going to check the condition at the beginning. Therefore, maybe if the condition is false, like in this case, your instructions, the ones that you have inside, are never executed. While, 0 or more. Do while, 1 or more. Just because you move the condition from the top down. If you have something that needs to be done at least one time, always, do while is your statement. If you have something that needs to be done 0 or more, I mean, something that maybe do not happen if the condition is false, then while is your choice. That is the only reason, because you select one or the other. If you want 0 or more, 1 or more. And as you can notice, the grammatical structure, the rule is almost the same. The only thing is, well, Here, I need a different word, and I need this semicolon, the beginning at the end. And the condition is with the while down, or in the other case, the condition is with the while up. Similar behavior. The only thing to remember is one or more, because as you can notice, now the condition is down. So you do this at least one, and then with the condition, you decide if you want to, again, true, or continue because it's false. Examples. This program is, hopefully you notice, the same that I showed you before with printing the numbers 2, 3, and 4. Did you notice my do and my while? Yeah, in my example before, I mean, going back to the chat, in my example before here, this instruction is run, is executed only one time, even though the condition is false. Obviously, if I put a condition here, like that one, I can make this true and run more times, not only one. But the minimum is one. In the while example, the minimum can be 0. So talking about the minimum number of times is 0 with the while or 1 with the do while. But for instance here, I am creating an infinite loop, just like I did before with the while. I mean, if you think about this one, the value for x is 1, the condition is checking lower than then, and because I am not changing the value for the variables, this one is going to be an infinite loop, just like we did before with the while. The thing that I need to do here is maybe something like, well, x equal x plus whatever I want to, just to change the stimuli. And my question here is how many times this do while is going to run. One, two, three. How many times x is going to be lower than then? First time, condition is going to be what is going to be the condition that I'm going to check the first time? 1 lower than 10 or 3 lower than 10? The first condition that I'm going to check. X is 1. Go inside. Print hello. Good. X equal x plus 2. X is 3, right? Here. Go down. Check the condition. What is the condition that I am checking? 3 lower than them. I never check 1 lower than them because I change the value of the variable inside, right? So the first time I'm going to check 3 lower than 10 is going to be true because it's true. What is going to happen? Go up. The next time I'm going to check 5 lower than 10, right? The next time, 7 lower than 10. The next time, 9 lower than 10. The next time, 11 lower than 10. How many times this program print on the screen hello? 5 or 4? Print, 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 because you check the condition down, right? So in this case, print hello 5 times. If you do exactly the same program, but you move the condition up with a while, you only print 4 times, right? Because this one is false at the top, you never print. In this case, this one is false, but down, you already print. play with this program, play with the previous one. Very, very important. So also play with this one. Whiles and do whiles. Whiles inside of whiles. And why not? Do whiles inside of do whiles. It could be another option. This example, just to close, it is printing a 2. Why? It's running only one time. Why? What do you need to check in my source code to tell me why this number 2 is just printed one time? Oh, the conditions. Now we are talking the same language. Is if you have a loop and you need to review something in the loop, the thing that you need to review is search for the condition. So whatever is my question here is, where is the condition? Okay, the condition is here. And the condition is, it doesn't matter which variables I am using or what instruction do I have. The condition is 10 greater than 100. That one is going to compile? Yes. That one is going to run? Yes. It's a perfectly good condition in terms of the language. But we know that that condition is always going to be false, right? And because the condition is always false, well, go down, go down, go down, execute the print, go down, condition is false, go down, the program finish. Never the loop go through. Conditions, very important. Locate and review the conditions when we start playing with loops. So, while and do while, review the examples, play with this, and in particular, I'll give you this example a little bit longer. A do while here with a while here. Can we agree that the while in the line 10 is not the closing of the do in the line 8? How do I know that? 1, the line 10 do not have a semicolon. 2, the line 10 is not closing the curly brackets, right? So in this example, I have a do while, and inside I have this one. Again, a loop inside of a loop. And I need your help. What is going to be the result of this program? I am going to stop here. This topic is chapter 4 in your textbook, just in case you want to review. Check the programs, run the program, practice, while and do while. We are going to have labs about this in the following days. Any last question? Good? Okay, guys, see you tomorrow. Thank you.